test 2 analysis. So let's start with the first question. This I did correct. I took about 3 minutes and 23 seconds in this question. The question is, suppose that we have two relations, A which has attributes x comma y, and then we have another relation B which has attribute x comma y. It is mentioned that they have the exact same schema. So by that we should understand that they have the same table design, not the instances but the same table design. That we can see from the attributes itself that they have the same schema. Also it is mentioned that there are no null values. No null values are there. So it is asked which of the following equalities hold in the relation algebra, and the options are A intersection B is equal to A minus B. B is A intersection B is equal to B minus A. C is A intersection B is equal to A natural join B, and D is A intersection B is equal to A cross product B. So these are the options. So since they have the same schema, we can understand it with the in terms of sets as well. That is, we have to calculate A intersection B. So basically these are two sets, A and B, and this is what we are trying to find. So will A intersection B ever be equal to A cross product B? Here cross means the Cartesian product. So if we take an example also, let's say this is schema A, 1 2 3 4 5 6, let's say, and then B has 1 2 4 7 8 9. So what will Cartesian product do? It will list out 9 tuples, 3 into 3, it will list out 9 tuples where we will have 1 2 1 2 1 2 4 7 1 2 8 9. So we can see that it is not giving us the intersection of the two sets, because that would have given us 1 2 only. This is what we would have got via intersection. So D is wrong, so we can eliminate option D. Then we have the rest of the option. Then will this be equivalent? Natural join happens where we equate the overlapping attributes, and here A and B are overlapping. Sorry, X and Y are the attributes which are overlapping. So as the resultant of the natural join, we will be getting X and Y, and since we are doing natural join, both of the overlapping attributes should be same, so that would give us the intersection only. So hence this option C is correct. Then we have option number B, that is A intersection B is B minus A. So let's see this, whether A intersection B is equal to B minus A. So let's say we have this is our set A, this is our set B. So B minus A, what would B minus A be? So we are eliminating portions of A from B. So this will be B minus A. This is B minus A. So basically this part, this is B minus A. And if we remove this from the rest of the B, so what after doing this B minus A, so this will be the remaining part. So this is nothing but A intersection B. So this is also correct, right? Yes. So this option is also true. Then moving on to A intersection B the first option, a minus b. So a minus b, we have to remove b from a, computing this, so we will be getting this. So this is a minus b, and if we subtract it from the a itself, then what we will be left with, this. This is nothing but a intersection b. So this is also true. So what's the takeaway? The takeaway from this question is, if the two relations have the same schema, then intersection of the two can be written in these many ways. That is, it is same as a natural join b, it is same as a minus b, and it is same as b minus a. So if the main takeaway is that they have to have the same schema, that is the same set of attributes, then only this is possible. So the correct options would be A, B and C. This is the correct option. Next question is, consider the following relation schema. This I took 3 minutes and 54 seconds and I got it correct as well. So the question was, consider the following relation schema. Where R is a comma b, and then we have another relation T with attributes p comma c, and the instances of these relations are also mentioned. So R a comma b has this tuple a comma b, then it has another tuple a comma c, then this tuple c comma d, and another tuple b comma e. Then we have this relation T with attributes b c, and these are the tuples b comma e, d comma h, b comma f, a comma d, and this tuple a comma e. So what is asked in this question, asked is to find the total number of rows. What is asked is, how many rows are present, in the result of the following relation algebra expression using left outer join. So what we are doing, left outer join, and we have to find basically the number of tuples. So we are projecting a comma c, and we are doing our left outer join on T. Okay. Our left outer join on T. So as we can see, the common attribute that we have is B, so it will be joining on B, left outer join. So what is outer join? It is just an inner join, but it will, whatever values on the left relation which will have no matching with the relation on the right hand side, we will associate it with null values. So basically it's same as the inner join, just that for the tuples which have no relation, two tuples in relation on the right hand side, we place null values against them. So it's just an extension of the inner join. Okay, so we are doing left outer, right outer join. This is okay, sorry, this is notation for left outer join. So we have to do left outer join. So on the left we have R. So when we are joining it, what we will get, this is B. So here we are matching. Are we matching anything? D is here. Then Nobody starts with an E, nobody starts with a D except this, nobody starts with a C except this. Okay, so this starts with a B as well, and this starts with a. So how will the left outer join look like? It will look like AB BE, AB BF, CD DH, CD DH, and for the these are known as dangling tuples. These are known as dangling tuples. These are also dangling tuples, but since it's a left outer join, we are only interested in the relation on the left hand side. If it would have been the full outer join, then both of them would have been considered. So these will be mentioned as well, AC, and these are basically notation for null. We can write null as well. These are both the same things. So now we have to, so this is A, and then this is B, this is C. This is basically the same thing. So we are projecting A and C. So we are projecting A and C. So basically these tuples we are projecting: AE, AF, CH, A null and B null. So the tuples that we will be getting is 5. So this was an NAT type of problem. The answer was 5. Next, moving on to question number 3. So question number 3, I got this correct as well. I spent a total of 5 minutes and 4 seconds, which is a lot more than what I should be giving to questions. So this has a relation R, a relation S is also given. So as we can see, they have the same relation schema, and there is a relation given, that is this is selection operator. This is selection operator, and this is the condition given, that is A should be greater than C. And inside here we can see it is written as R union S minus R minus S minus S minus R union S minus R minus S. So what will be the simplified version of this? So we are taking the union of R and S, and then we are subtracting R minus S. So R minus S would be this. So what we are left with is S itself. So S minus R, as we saw earlier, is S intersection R, right? So S intersection R, and where S and R have the same relation schema. So basically they are the same. This is the same question as the question number 1, right? So the options that are given, basically it is asked that which of the following is equivalent to the above query. So the options are selection A is greater than C, and R, this is natural join. So as we saw that natural join is same as intersection of the two relations, so A is correct. Then we have selection operator with A with the same condition, and R union S. So this is wrong. B is simply wrong. We have option number C, where we have the selection operator with the condition A greater than C, and then R intersection. Okay, so this is one selection operator on this, and then it's an intersection over this set, that is selection with the condition and S. So we can write this R intersection S as applying the conditions separately, that is selection A greater than C on R intersection selection A greater than C and S. Both of them mean the same thing. There is no difference. To apply the selection operator on this set is same as applying the selection one by one on both the sets. So option C is also correct. Moving on to option number D. That is selection on the given condition A greater than C is equivalent to R intersection C. So we know that this is correct. So the answer is A, C, D. Got it correct, but took a bit more. Moving on to question number 4. This also I got correct, and I got it correct within 1 minute 40 seconds. Question number 4. Selection theta R cross S divided by R, and then we have T2. So basically whatever the result we are getting from this relation operation, we are storing it inside the relation T1. So that is what it means. So theta is basically some condition, theta is basically some condition that we are applying on this relation that we are getting from this relation algebra manipulation that we are doing. See, selection on theta on the relation S. Then we have a relation T3, which is obtained by applying the selection theta on R. So that would be in T3. Let's say to understand this, let's take an example. So this relation R, let's say it has the attributes n comma c. N is basically name of students and c is the course that they are enrolled in. S is also a relation which mentions the name of courses, So the name of the courses mentioned are maths and physics. So the value returned in R division S value that the values returned in R division S will be basically a function of what? Function of n. It will be a function of n, that it will return only the names of the students. It will only return the name of the students and the name of the students which have total association with all the courses mentioned in the S relation. That is, A is related to M and P, so A will be present, whereas B is not related to any one of them. C is related to both of them, M and P, so C will also be there. But if we had a D which had only association with maths, then also D would not have been present here. Okay. And then we are applying some condition here. It does not matter, right? It does not matter. So if we are doing this, then we are getting S only, right? There's a relation R, and then there's a relation S, and then we are dividing it with R. So let's say, so basically it's a cross product, right? So let's say R had all the names of students. So let's say this was ABC, and S was the courses. Let's say this is maths and physics. So cross product of it would have led to this type of relation. Let's name them P with attributes N and C. A with physics, B with maths and physics, C with maths and physics. So now when we would have done P n comma C divided by S, we would have got R back, right? So R multiplied by S divided by R would have given us S. Obviously, in terms of like very basic mathematics, this also looks right, but in terms of relation algebra, it's different. If we would have done R multiplied by S divided by S, we would have gotten relation R. So here what we have done, R multiplied by S divided by R, so we will be getting S. So the answer of this question is that T1 and T2 are equivalent relations. So that is only there in option number C, that T1 is equal to T2. So this was question number 4. Moving on to question number 5. What was question number 5? I got this question wrong. Did I get this? No, this also I got correct. I spent a total of 3 minutes and 31 seconds in this question. Basically the question was that it had an SQL query. With these relations. We had a Sailor's relation which had the attributes SID, SName, rating and age, and we had a relation named boats with attributes BID, BName and color. Then we had another relation named as reserves with attributes SID, BID and day. And the SQL query was select s dot sname from sailors S, comma, reserves R, comma, boats B. So what we are doing here, we are simply doing cross product, and we are mentioning the condition where s dot sid is equal to r dot sid and r dot bid equal to b dot bid. So whatever the common attributes are there, we are equating them as well. So we won't be getting the Cartesian product, we will be getting rather the inner product, that is the natural join. So we are equating SID with SID of reserves and the sailors relation, and we are equating the boat ID of the boats relation and the reserves relation. So now what we are getting is basically the sailors, who have these particular boats reserved. We'll be getting this information. So it will be like we have sailors and we have its attribute SID, SName, rating, age. Then we have the boats attributes, color, SID of reserve, BID and the day it was reserved. So we are getting the attributes of the sailor who booked a particular boat on basically this is the information regarding its reservation, the day on and the boat number and the sailor ID who reserved that boat. So now the query, okay, so after where we have our ID and b dot color equal to blue and b dot color equal to white. This is mentioned. So as we can see that for a particular SID with a particular name, with a particular rating and age, We will be getting only a particular single color. This is not a multi-valued attribute. This is single valued attribute. So it will return a single value, that is a particular color, whether blue, black, white, green, whatever it is. And here the query is asking that the color of the board should be blue and white, which is not possible, since it's a multi-valued attribute. One of them will return true, one of them will return false, and since it's an AND operation, it will return false, and hence none of the tuples will be able to return a value, and hence what we'll be getting, we'll be getting 5, nothing will be returned, and hence we'll be getting an empty set. So that is only was there in option number D. So D was correct. Yes, I got it correct. Moving on to question number 6. This also I got correct, but I took how much amount of time in this question? So I took 2 minutes and 36 seconds. The question was, I think it was a fairly simple question. We were given an SQL query with the relation student, with the attributes SID, name of the students, marks of the students. Then there was another relation named as course, with the attributes CID, min, and max. Student relation has the following set of tuples. So the student relation had these tuples: 101 A 50, 102 B 52, 103 C 60, 104 D 70, and the course relation had these tuples: C1 20 90, C2 15 95, C3 10 100. So basically the query was select s dot sid. Basically we are selecting something from here, from student s, this table where exists select count star from course C, where s dot marks is greater than C dot min and s dot marks is greater than C dot max. Actually it's a very simple question. Why is it so? As we know what how the exist clause operates, it operates for whichever tuple this does not return an empty table. So if it returns anything for a tuple, it will hold true and it will select that particular tuple. So the only condition here is that it should return a non-empty table from here. In this, this is the subquery. In this subquery, it should be returning a non-empty table. And as we know that count star is an aggregate function. It will always return something. It will always return a count, whether be it 0, 1, 2, whatever it is. It will return that value, and because of that this will not be an empty table. This will be the table. This will how the inner query will look like. So this will be returning the count, and since it won't be an empty table, this will always return true. And since for all the tuples it will remain true, so all of these values will be returned. And what was asked in this question is the number of tuples that will be there in the output query. So all of these SID values will be returned, that is 101, 102, 103, 104. This will be the output. So we are supposed to count the number of tuples, so 4 is the answer. So actually it was a very simple question, just that we had to know that the exist subquery, how the exist works, and it basically returns a true value, a boolean value, to the query, and it will select all such tuples for which the subquery is returning a non-empty relation. So this was question number 6. Moving on to question number 7. Moving on to question number 7. This I got. This I did not even attempt also, and I looked at this question for 45 seconds, but I did not attempt it. Rather, seeing now, it was a pretty simple question. So basically the question is, let R equal to A comma B comma C. So this is a relation R which has these attributes A comma B comma C, and then we have another relation S which has the attributes C comma D comma E. Let Q and R be relation. Okay, so this is basically a set of attributes, and we are given the relation separately. That is, Q be the relation on R, and R be the relation schema on S, and R be the relation on S. So these are the two relations, and these are basically the set of attributes. So we are asked which of the options are equivalent queries. So we are given 4 options, and we are asked that which of the queries are equivalent to each other. So it is only projecting the tuples. It is only projecting the value, the A values, such that there exists a B, there exists a B such that A comma B belongs to the relation R and P is equal to 10. So this is the first. So this is the first relation that we have. Second is select distinct A from R where B is equal to 10. Select distinct A from R where B is equal to 10. Okay. Then we have select distinct star from R. Expect is basically like minus, how minus works, or the set difference. Select distinct star from S. Basically we are doing set difference here. Select distinct star from Q where A, B, C not in select distinct star from R. So as you can see, देखो यहाँ क्या कर रहे हैं, from Q and R. So basically क्या है यहाँ पे, और what we are trying to get here is that exact same set of tuples. So this would never return, है ना, क्योंकि we are using 2 different tables only. So 3 and 4 will never equivalent. So that was in option D, that query 3 and 4 are equivalent. So D was eliminated like that. Then C was 2 and 4 are equivalent. There is no such condition mentioned in 4. So 2 and 4 also are not equivalent to each other. Moving on to option number B, query 1 and 3 are equivalent. Query 1 and 3. Also this condition is not there, so 1 and 3 is also not right. So only option A was left, that is query 1 and 2 are equivalent. So looking at this, we are projecting only the row A such that there exists a B for A where A comma B belongs to the relation and B is equal to 10. That is, we want such A's which have association with 10. So basically what was A? So let's say A be let's say the age of the students, or name of students, and B, let's say, be the age. So we want all such students who have age, let's say 10. So it will list out A let's say the name of the student A, then there's a student who is named B, whose age is also 10. Then we have another student who has age C, name C and age 10. Then another student with name D and age 10. So this is what the output of this query, and we will be only mentioning the name of the student, that too since it's a tuple. If we have duplicate values also, then it will only be producing the distinct values. So that is what is happening here. Select distinct A from R where B is equal to 10. So we can see that 1 and 2 are equivalent, and hence option A is correct. I did not attempt this, though it was a very simple question. Only by option elimination I could have gotten the answer, but I don't know, because of this option I did not want to attempt it. This looked a bit tricky to me, but as you can see, it was a very easy option as well. Moving on to this question, it was also a very easy question. I took how much time? I took 2 minutes and 38 seconds. This is question number 8. So basically we had a relation student course. Name of the student was R and the course was database. Name of the student was R and basically the same name, and the course was programming and programming languages. Then there was a student named Sushi who took the course database. Then Sushi also took operating system. Then Julie took programming languages. Julie also took machine learning. Emily took operating system. So this was the student enrolled relation. So this was the enrolled relation. And then we had the to-do relation, which mentioned courses, which had database and programming. So basically D and B. So the query was select distinct student from enrolled where course in select course from to do. So this would give me database and programming. So we want the name of all distinct students. So how it is evaluated, what is the flow of execution? So first this from is executed, then the where clause is executed. So where course is in, so this was a subquery. The subquery was basically select course from to do. So this is what it would have given us, that is the data structure and databases and programming. So for every tuple we will match with it, that is from enrolled, this enrolled table, whether they have courses matching in database or database and programming, database comma programming. So basically it's an OR operation. If any one of them is matching, then it will return the value true. So this is the course attribute. So for the first relation, the first tuple, that is R comma D. So D is there, so this will pass. So this will pass. So this will come in the output table. What we are taking as output. First, just take all the tuples that is passing. R comma P. This will also pass. R comma P. S comma D. S comma D will also pass. S comma O won't pass. J comma P will also pass. J comma N won't pass. E comma O also won't pass. So these are the set of tuples that have passed the where clause. So now we will go to select. So this is this is executed at the very last. So select distinct. So when we do that, we will be getting only the distinct student name, that is R, S and J. So that is asked how many tuples are finally returned. So the answer is 3. Moving on to question number 9. This I got incorrect. This I got incorrect. The question was from SQL only. I dedicated how much time in this? I dedicated total of 5 minutes and 10 seconds and I got it incorrect as well. So basically it's the same question that we had on the. So the query was select s.sid from sailors S, reserves R, where S dot rating was equal to 10 or R dot bid was equal to 4. So what we did here was we did a cross product and I mistook it as a natural join. I thought of it as a natural join, but it was actually a Cartesian product. So this was the error. This is a as we do it here, we will always take it as a Cartesian product, and in the where we mention the conditions regarding the natural join. So this was the mistake that I did. So when we do this, we will get all the sailor IDs corresponding to one with r.bid equal to 104. So as a result of what, when we will be doing select s.sid, we will get the SID of all the sailors. Where I mark that the output of the SQL query will be the SID of the sailors who have rating 10 or have the boat reserved BID equal to 104, which was wrong. This was correct. So moving on to question number 10. This also I got incorrect. I spent a total of 8 minutes and 49 seconds, which is truly dreadful stuff. I don't know why I spent so much time and still got it incorrect. Assume we have two relations R a comma b and S b comma c. All three attributes a comma b comma c are integer attributes. Assume that relation R contains the following tuples: 1 comma 2, 2 comma 3, 3 comma 4. S contains the following tuples: 2 comma 2, 2 comma 3 and 5 comma 1. It is given that this represents a natural join. In the following expression, which of the following relation algebra expressions are equivalent with respect to the above information? So we were asked that which of the relational algebra expressions are equivalent to each other. What I understood that with the given statement that which of the following relational algebra expressions are equivalent comma with respect to the above information. So I thought that we are just talking about the equivalent tuples that we are getting. So not the exact logic should be equivalent, but the tuples should be the final tuples that we are getting out of the two relations should be the same. So that was my interpretation, which was wrong. I think that the question could have been framed better as well, that we could have dropped this line altogether, that with respect to the above information. I think that it caused some confusion. So the first option is we are projecting A over the condition that B is equal to 1 over the relation R, and we are using the selection operations, so that b equal to 1 over the projection of a r. So as we can see that this is not even a subset of b, so this would be an invalid operation, hai? This would still be valid. Would this be valid? Yes, this will be valid, but this would be invalid. This is still a valid expression. This is an invalid expression. This would return an empty table. This would return an error. So one is not equivalent, which I marked that both of them will not be returning anything, which was wrong. Rest of the options I did correct only. That as you can see that here the selection and the projection operation that we are using are being operated on the same attribute, so they can be exchanged. We are operating on the same attribute, so they can be exchanged from one place to another, so they will be equivalent. So 2 is equivalent, that basically this relation algebra operation is equivalent to this relation algebra operation. Next is option number 3, that is we are projecting a comma b over r and s, and so this is one operation and this is the second operation, that over r we are doing, and then we are multiplying, we are doing the Cartesian product over s. So as we can see that what would have happened, that we are doing first the what is it, natural join, and then we are projecting a comma b attributes, and we are taking ab, and then we are doing the natural join. So as we can see, if we are doing the natural join here, then we are getting 1 2 2 2, and this is the only thing that we are getting, right? So we are only getting 1 and 1 comma 2. This is the output of it. If we do the cross product, if we first project a comma b, actually this is r itself, right? Because r has nothing else, so this is basically r natural join s only, r natural join s only, and we will be having a comma b only as the final set of attributes. So this is actually the same thing written in a different manner. We are projecting a comma b, we will be getting a comma b naturally from here, and what we are doing is the natural join here as well, and here we are doing the natural join itself. So yes, they are also same. Now on option number D, what we are getting is we are doing the selection operation where b is equal to 1. Wait a second, yes. And then we are doing the natural join, and then we are doing the selection operation on r, and then we are doing on s. So will the two be equivalent? So here we are doing natural join where b is supposed to be 1, and so as you can see that this will return nothing. This will also return nothing because b is not equal to 1 in both the relations. So so according to the tuples that we are given in both the relation, both will be returning 5 values. But is it logically true in all the cases? That we need to verify, because here we are applying the selection over the entire natural join, and here we are doing the natural join the selection on r, and then we are doing the natural join on s. So are they the same thing? So basically what here we'll be getting that we'll getting all such relations where the value of r is 1 and then we are doing the natural join. Let's just take an example. Let's say it was some other relation. This is AB and this is BC. This is R and this is S. Let's say 2 1, then we have 3 1, then we have 5 2, then we have 7 1, and BC has, let's say, 1 2, 3 5 1 7, 2 1 है ना. Let's say 1 2 repeat तो नहीं हो सकता since they are relations. Relation is a set of tuples, not a bag of tuples, है ना. SQL is a bag of tuples. So let's say if we are doing this first, that is we are filtering out 7 1. So this is the filtered out, and then we are doing the natural join. So we'll be getting 2 1 2, then we will be getting 3 1 2, then we will be getting 7 1 2, then we will be getting 2 1 7, 3 1 7, and 7 1 7. This is the output from this query. And if we do here our S, then we will be getting 2 1 2, 3. This will result the same, that now we'll be filtering out the these values. So yeah, these are also logically equivalent. So I marked actually option A, B and D. I marked for this as well. This was option number A. This was option number B. As you can see, C was false. I did a blunder here as well. S had attributes BC. Here we would have gotten AB only, and this would have gotten us A, B and C. So this can never be equivalent. So I had marked A, B and D. C was obviously wrong, as we saw, but I did not judge the option number A well. So the correct option was B, D. So this was the 2-mark question. Moving on to question number 11. This was a fairly simple question. We were asked that we are given two relation schema, and and we were asked that given relation R and S, let function C denote the number of result in the output. That is basically judging the cardinality of the relation, and which of the following statement can be correct. And we had to discard the statements which are never possible. So the first statement was C R, this is natural join and this is this was right outer join, right? This is what, no, this is left outer join. So as we can see that it will never have more that inner join. This is inner join, right? Inner join or natural join. So natural join can never have the total number of tuples greater than left outer join. So A was false. Then we have statement number B, which has R is greater than for the number of tuples in the left outer join is greater than the number of tuples in full outer join. So no, max it can be equal, but it can never be greater. So B is also false. Next, option number C, we have that the full outer join has greater than the right outer join. So yes, this is correct. This can happen. Then we have that left outer join can have cardinality greater than the right outer join. Yes, this is also possible. So C and D, that is option number 3 and 4 are correct. So I marked option number D. So yes, this was correct. Moving on to question number 12. This was a very good question. Actually, it took help of the pigeonhole principle as well. This was a very, very nice problem. So the question was that for a simple undirected finite graph, we have a simple undirected. What is the definition of a simple graph? That it does not have parallel edges and it does not have cycles. Parallel edges not there, cycle also not there. So we have a simple undirected array. We have a simple undirected graph. Some graph degrees are stored. So basically we have a database where we have the name of the vertex and then we have the degrees associated to it. Let's take a very simple example. Let's say this is one such graph G vertex comma E. What are E? E is basically your set of edges and V is for vertex. So what is the degree of A? So degree of A will be the number of other nodes that it is associated with. The degree of B is 3, as we can see. Degree of C is 1. Degree of D is 2. Degree of E is also 2. Degree of F is 1. So how it would be in this database? So the name of the vertex is A, degree is 1. Name of the vertex is B. For B, the degree is 3. For C, the degree is 2. For D, degree is 2. For E, the degree is 2. For F, the degree is 1. So this is the database that we have here as well. So the question says, for a simple undirected graph G, graph degrees are stored in a database table. The name of the relation is dig G. This table has two attributes, V and D, where V represents the vertices and D represents corresponding degree of the two vertices. If Vi is some vertex of degree Di in graph G, then there will be a row Vi Di. So this is what we are talking about. This is Vi Di. V is the primary key. V is the primary key. We can identify any of the row. As we can see, obviously, a particular vertex won't be repeating. As it is mentioned that V is the primary key. So we have a total of 100 vertex in this simple graph, and we have to find the sum of maximum and minimum possible value of pi d degree of G. So in this relation, and this represents what? This represents the cardinality. This represents the cardinality. So there will be, so the max cardinality of this would be if we get all of these as unique, you know. So if we have, let's say, n vertex which is equal to 100 here, if we have n vertices in the graph and they are simple undirected, then the maximum degree will be n minus 1, you know. Then the maximum degree will be n minus 1 and the minimum degree will be 1. So the total number of distinct degrees that we have is from 1 to n minus 1, that is n minus 1 choices. N minus 1 choices, and we have n vertex to assign it to. So it's like we have three, so we have 3 colors to paint 4 walls. So by pigeonhole principle, it will say that at least one wall will have 2 of the same colors. That at least 2 walls will have the same color. Sorry. So let's say we have 4 walls, and let's say this is another wall 2, wall 3, this is wall 4, and we let's say we have only 3 colors. So there will be a case, the only possible resolution is that 2 walls will have the same colors if we are trying to like maximally use all the colors. So this is how the pigeonhole principle works. It says that if we have n minus 1 slots for n birds, then 2 birds will be sitting in the same hole. So that is the pigeonhole principle. So the same thing can be applied here as well, that we have 100 vertices. So the maximum degree can be 99 and the minimum degree can be 1. So we have 99 choices for 100 vertices. So at least one will repeat. So we have total of 99 distinct. So in this tuple cardinality, we will get maximum 99. And in case of minimum, all of the degrees can be the same. It happens, let's say अगर मान लो कोई cyclic graph में, तो सारे का डिग्री क्या है, 2 2 2 2 2. So if we do the set cardinality, then what we will get 1. So in such a case, this will be the minimum value, this will be the maximum value. The summation of this will be 100. So this was a very nice question, actually very simple, but had to do some kind of analysis. So I spent 10 seconds. I just looked at the question and it looked tough, and I did not attempt it. I could have made better decision and spent less time in that question than this question. So this was question number 12. Moving on to question number 13. This I did not attempt actually. Actually question number 13, 14, 15 was out of syllabus. I have not read the theory for these questions, so I'll attempt them later. So I attempted 10 questions. 2 I knew, but I did not attempt. In these 10 questions, I got 8 correct, and I got 2 wrong. So my test stats were, let me check. I attempted 10 questions, got 8 correct, 2 wrong. I got total correct marks is 11. Penalty was 0.67. My resultant marks was 10.33, which is very bad and a very poor performance.